Now, to arrive at the final equation in my ground potential paper, there were a number of what you would call inventive steps. Not only realizing that potential is limited, but also realizing a few more things. Now, one of those is, if potential is limited, that means that potential has a range. Now, we can assume it ranges from 0 to 938 million volts. That's a large range. It's a very large range in a potential voltage. Now, the thing which I immediately realized after discovering the potential limit is that ground potential, which is the potential at which we are, must exist between 930 or between 0 and 938 million volts. But where? Where is ground potential? I mean, should we be so naive as to think that ground potential must be in the middle? Well, maybe not. There are reasons to believe that ground potential is at the same potential as the nucleus of nickel-62. Now, why nickel-62, you might ask? Well, you see, the table of binding energies peaks at nickel-62. That table of binding energies is upside down. In fact, it is not, binding energy is not an energy. What they call the highest binding energy is in fact the lowest nucleus potential. So when we turn the table of binding energies upside down, you will see that nickel-62 is right at the bottom. It is the point at which nuclei can fall no further. In this way, we can view nuclear fission reactions as decay processes. And likewise, we can view nuclear fusion reactions as decay processes. And these nuclei will decay until they can decay no further. And that is why nickel-62 is at ground potential, because we are at ground potential. It can't fall, water can't fall any further than ground. And this is exactly what we are seeing in the nuclear isotope table. Nuclei that are at higher potentials than current ground potential will decay towards the ground potential where the observer is. Simple. And once I realized that this was the case, nickel-62 became the key to unlocking the true nature of ground potential. It was the number to which we had to match our equation in order to discover the truth behind potential. It wasn't difficult. I sat down on a Sunday peacefully in my room to see if I could hack out the equation for ground potential. And I tried one number, I tried a different number, I tried a few different arrangements of what I knew. It wasn't long until I had a number which perfectly matched nickel-62. And I knew that we now had the equation that not only tells us the minimum and maximum potential, but also tells us ground potential where we are. And I now know that I am standing at 930 million volts. And that is the potential of the Earth. Now, the consequences of what I have discovered here is numerous. First of all, it appears very likely that ground potential is in a state of constant decline. How do I know this? Well, if maximum potential was 938 million volts and today's potential is 930 million volts, it is very likely that we are in a state of ground potential decline. Now, assuming that our current understanding of the age of the universe is remotely close, 13.7, 13.8 billion years, and we assume that ground potential has fallen some 8 million volts over this period of time, then it looks like, it appears to be, that ground potential is falling by approximately half a millivolt per year. And with the current rate, or with the current ability to measure the mass of an electron, it is going to take us some time to actually prove this fact. But the proof to this theory will be to prove that the electron is changing mass over time, and that ground potential is falling, and likewise that the electron mass is rising slowly over time. Now, it's going to be difficult to measure. If ground potential falls by half a millivolt, the electron potential will rise by a tiny, tiny fraction of that. So as our measurement techniques improve and as time goes by, we will eventually be able to measure this tiny difference and prove that ground potential is indeed correct.